All right, so I'm going to go over this quick problem from CS173 algorithm section. We have a function named hoist that takes an array. Okay, so let's underline that. An array of positive integers. It's got two base cases here and here, right? They take different amounts of time. One just is a constant return. The other one adds it and then returns it. So it takes a little bit more time. So these are slightly different. And then our recursive definition here, right? Um, Here we just split the array into thirds, right? So just imagine like an array here, right? Into thirds, this would be P and this would be Q, right? These are just pointers to that index. And we have our two recursive calls here, right? So we know it's two times t of something, right? So what is this something? Well, it's the size of the input to the or the subproblem, right? The size of the subproblem. In this case, looks like it's taking this third and this third. So it seems to be that it's taking thirds. So we'll just do it two times t of n over 3, right? Because it's a third of the original subproblem. There's two recursive calls there, right? And then it does some like max work, right? Which is like some comparison there. And then the other important one is this one, right? This one seems to take all the numbers from P to Q, right? Right here. And it finds a max number there, right? Compared with the original max numbers from the left and the right. So this one seems to take a third of the original subproblem and it loops through all of it. So this is basically O of n, and we can rewrite it into dn, right, as a sort of like a constant, a linear amount of work per recursive call, right? So overall, our um our recursive definition should look something like this, right? We have t of 1 equals some constant, right? It's basically around 2. T of 2 equals, and this, just make sure, a lot of people trip up. T of 2 does not equal a1 plus a2. This is, again, we're trying to find time, not the actual return value, right? Because it's not the actual return value, the time it takes for this is going to be a different value, right? It's going to be some other constant, in this case, b, right? Because as you can see here, it's just like a regular addition operation on two values. So it takes some amount of time to do that, which is different than T1. So we'll just denote it with another variable here. And then our recursive definition here is, the original recursive call and the work it takes for that. So there's two recursive calls, each of a third piece, right? Plus d of n. Where's d of n coming from? It's coming from this for loop right here. Okay, so if we write it out, right, t of 1 equals a, t of 2 equals b, t of n equals 2 times t n over 3 plus dn for n greater than 2. Okay, that's about it.